Alright, we're gonna do. So we're starting confidence intervals, which is a fairly major topic. And what I like to do, and seems to work best, is I'm gonna kind of write an essay almost, or like a proof. We're gonna write out like this 1-page summary of what we're doing, why we're doing it, what it means, how we're doing it, all that. And as we're going, so I got two options. I can show you like what all the little pieces mean, and then put it all together, or I can do it all at once, and then we'll go back and like identify what the pieces mean, and I'm gonna do it all at once. So I'm gonna go through this process, and you're gonna probably be like overwhelmed with what's going on, and just that's okay. We're gonna do it more. We're gonna like break it down eventually. It just seems to work better when I do it all at once first. So you can see the big picture, and then we start like breaking it down. So what we're doing is a 1 proportion z integral. If you go to, wait, hold on, let me make sure I'm calling it the same. Your calculator calls it a 1 prop z integral. So that's fine. 1 prop z int is what your calculator calls. So the idea is I've got this big population here. This is P, population. And I'm going to use, like the board is meeting tonight to decide about whether masks are going to be mandatory starting on, I think it starts on Monday. Whatever they decide, if they decide but it's not mandatory. I'm going to use that as our example. So I want to know what the whole student body thinks about this. But I don't have the whole student body. I don't want to. I'm just too lazy to go ask. And I'm going to pretend that you guys are a simple random sample. You're not. But we're gonna make some pretending. But I want to know, like, is it okay if I ask you your opinion on that? Is everybody like unwilling to share their opinion? Like if I said how many of you want masks to be optional, does that make anyone uncomfortable if I ask that? Okay, raise your hand if you want masks to be optional. Okay, so I got 11 out of like 16. We're gonna pretend, so this is our sample. Right here's our little sample, our little slice of the population. We're gonna pretend our p hat was 20 out of 30. Hold on, I want like an even decimal. 20 out of 32. But is it fair for me to say that because it's 20 out of 32 in here, that percentage would apply to the whole school for sure? It's not. But is it like a reasonable starting point? Yeah. So that's what a confidence interval is. We get like a starting point where we think, okay, I got this data, and then I get like a margin of error. So this is 62.5%. And then I'm going to get like a margin of error on each side, and I can say, well, if I know that 62.5% of you people think that math should be optional, I can assume it's like 62.5% plus or minus a certain amount of the whole school. And we're trying to, I want to know the information about the whole school, I just don't have the whole school. So I'm taking my little slice. So P is equal to the true population proportion of students that want masks optional. So P hat is my sample data. I know that. I'm not trying to guess what that is. I have it in front of me. You guys just raise your hand and I wrote it down. I'm trying to use this small slice of the pie to make a bigger assumption about like the whole school. So that's what stats, but this is a big part of stats. It's called inference. I take a small slice of data and infer that to a bigger population. So we want to estimate P. What does P represent? That's the true population proportion. At a, let's say it's a 95% confidence level. And that can change. It can be 90%, 99%. What's up here?
That number picked because of the type 1 type 2.
do with it eventually. It's more picked because like 95% is like 2 standard deviations each way from the mean. So that's where that comes from. If I went like 99%, now I'm going like 3 standard deviations. So the higher that number is, remember, if you want to like be 100% confident that you're guessing my weight, what are you going to say? 0 to infinity. So the higher that number is, the wider your margin of error gets. So if you want to say, you have to be correct on my weight is between these 2 numbers you tell me or you die, then you're going to say 0 to a million. So the higher your percentage needs to be, 100%, you're going to make that interval like super long. Is that what you're asking? Okay, before we can do this process, there are conditions that have to be met. One is there has to be randomness. And we are going to assume, or in this case, kind of pretend, you guys are not a simple random sample. Is it? I don't know if it's likely, but is it possible that AP students feel differently about masks than non-AP students? I don't know. I mean, probably not, but is it possible? Sure. So, it's technically not okay what I just did, but we're just kind of trying to demonstrate a process here. The second thing is that we need at least 10 successes and 10 failures in our sample. So we had 20 yes and 12 no. So is that at least 10 of each? It is. We're good. So I'm getting that from here. We have 20 people say yes, math should be optional. And then 12, right? Because 32 minus 20. 12 said didn't say anything, which means I guess the opposite. The third thing is we need independence. So you want your n to be less than 10% of the population. I'm kind of cheating on this one. Well, no. So how big was my sample? What's my n? Say 2. 32. My n is 32, right? So there needs to be at least 320 students in this school. So that I'm taking less than 10%. Are there 320 students in the school? Barely anymore, but yeah. So these 3 conditions need to be met. And if they are, I can proceed. I should say this too. I'm going to let you use, we're going to do like a bunch of examples, and we're going to make a template, which is like a guideline or a cheat sheet, and you can use that on the test. So you're not going to be asked to memorize all this stuff. So those are my conditions, which I'm allowed to proceed. So now I'm going to do, this is kind of like my intro, my conditions, now I'm going to do my method. So, formula for a confidence interval is the statistic plus or minus what's called the critical value times standard deviation of the statistic. And that's every confidence interval. We're going to do like 4 different kinds. But every single one has the same starting point. Remember, statistics come from samples. So the statistic is like what I just learned. That's p hat in this case. The hat means it came from the sample, or if you go back up here, remember the hat is like indicating like the little slice of the big picture. The critical value, put z star. And then the standard deviation of the statistic is the square root of p times q over n. So you write out the formula in words, in notation, then we're going to put in numbers in all those slots. 20 over 32? Yeah, RP hat is 20 over 32. Okay, Z star. What you're going to do here is type into your calculator inverse norm of 1.95 divided by 2. Where did the 0.95 come from? Because it's a 95% confidence interval. If this was a 99%, you would do 1.99 divided by 2. If it was 90%, you would do 1.90 divided by 2. So let's just make sure we all get the same thing, type in that in. So the inverse norm over that second bar, 1.95 divided by 2. If you have the kind that gives you like the prompts, just leave those as 0 and 1. If you have the kind without the prompt, you don't have to type anything. It would just look, well, you don't need the 0 and 1. But you should get 1.96 for that. If you don't get 1.96, let me know so I can come around and see what you're doing. It's like 1.959999. So, inverse norm 1.95. Is that not what it says? No, you got it? Some of the calculators are weird, like you have to put left on it. So 1.95. That's here. No, divided by 2. So, P is 20 over 32. What's Q? Q is the probability of failure, or the opposite. So it's 12 over 32, right? Because 20 people said yes, so that means 12 people said no. And how big was my sample? It was 32. Did the formula with words, the formula with notation, the formula with numbers. And now we're going to go to our calculator and make our calculator tell us, it's going to give us the interval. It's going to give us like between 1 and 1. So, calculator up. And again, like if you get stuck, let me know. I know it's not easy to follow calculator stuff. We're going to hit stat. So I write these steps down. Stat. Go to tests. And then go to A. 1 prop Z int. So right there. And then go ahead and enter. So you should see that without, you probably have, I don't know if you have numbers there or not. Doesn't matter. But you should see like that X and C level calculator. Does anybody not see that? So what you put in is P hat, but you put it in like as a fraction. Like it's almost like, you just pretend there's like a fraction bar here. You're going to put 20 over 32. You're putting 20 in for the X, 32 in for the Our confidence level is 95%, so we put 0.95. Yeah. It is not. We do that too, but that's not yet. There's intervals and tests. Those are like the two main things we do from here on out. Someone else need me to look at theirs? I got a question. Satarina, you good if I keep going? So go ahead and calculate. And that's the confidence interval. So what it's telling you is our p hat, our sample data was 62.5%. Based on the sample size, I'm 95% sure that the true answer for everyone in the school is somewhere between 45% and 79%. That's a pretty wide window because we had a small sample, so it's hard to like make a strong statement about that. So go ahead and write that down here. 0.457 and 0.792. And then we're almost done. Our only job now is to make a conclusion. And then I'll kind of step back and say, like, all right, let's look at the whole thing. Talk about it. So our conclusion is we are 95% confident that P lies between 0.457 and 0.792. There's your whole process. So your test will probably be like 2 of these and some multiple choice about it. But again, you will get like a guideline or a template where I'm like I go through and like write down what you should put in each slide. Questions I can answer at this point? I mean, I know it's like that's a lot of crap, but is there anything like specific that you're like wondering about right now? So again, just to like think about the process, I want to know about the population. I want to know about all the students at this school. I take my simple random sample, which all just happens to be sitting right in front of me. It's amazing. And I find out 20 out of 32. But I can't apply that to the whole, so that's like 62%. I can't say because you people, 62% want math optional that the whole school does. I have to have like some margin of error because I don't have a ton of data. So that's what this process works through. It's like, okay, if we know 62.5% of these 32 people, then I'm confident in saying that I'm pretty sure the true answer for the whole school is somewhere in between there. Questions I can answer? Alright, let's do another one. Let's say, make this a little less controversial. One proportion, the interval. This is my big population. I'm going to take a small slice of it. And I found out that 150 out of 200 people have cereal for breakfast. How many of you guys have cereal every morning for breakfast? 0 of you? Seriously. Pop-Tart? Alright. So I'm going to let P equal the true population proportion of people that have cereal for breakfast. So the population in this case is like basically everybody in the world. I just said people. I took 200 of them. I want to apply that to like a bigger scale and see like, okay, I'm pretty sure the true answer is somewhere between this and this. That's what I'm doing. So we want to estimate P. And let's do a 99% confidence level. So that's our intro. Does it make sense what we're trying to do? Like take a small sample and apply it to a bigger picture? That's like the most important concept, I'd say. So I've got conditions. I need there to be randomness, but they didn't tell me that. So I'm just going to assume it was an SRS. Remember, SRS is like put all the names in a hat, mix them up, take a bunch, take some out, and that's your sample. Sometimes it'll tell you, and you can be like, the Project States SRS. Sometimes it won't. You're just like, well, I just assume it's SRS. Then you need at least 10 successes and failures. I have 150 successes. How many failures do I have? I have 50, right? Because that's the difference between the successes and the total amount. I have 50 failures. Those are both greater than or equal to 10, so I am in good shape to proceed. Do you see where I'm getting the 150 and the 50 from? And then my third thing is I need independence. So I need N to be less than 10% of the population. So is 200 less than 10% or less than or equal to 10% of all people? I would say so. Intro, conditions to meet to allow us to do the problem. Then we do the math. The formula is statistic plus or minus critical value times standard deviation of statistic. So, what's the statistic? What's the notation for the statistic? P hat. So P is population, P hat. A little Q hat on there. The statistic. Critical value is Z star. Standard deviation is the square root of P, Q over N. So you can use decimals or fractions for this. So like last time I put 20 over 32 here. Sometimes if the decimal works out nicely, it's easier to use decimals. You can do it either way. But like 150 over 200 is 0.75, right? That's a pretty smooth decimal. So I'm going to do it that way. I'm going to say 0.75 plus or minus. I'll find my Z star in a second. But then in here I can go 0.75, 0.25. What has to be true about these two things all the time? Add it to 1. And I had 200 people. And then for my Z star, that's going to be inverse norm 1.99 divided by 2. So we get there. So I get 2.58. And rounding doesn't really make a big difference because we're not typing this in. Like, I'm never going to type in this math. I'm making the calculator do it for me by doing that process. It just does that on its own. So again, I did it, the formula in words, in notation, and then in numbers. Questions? I heard mumbles. Can I help? Yeah. 1.9, so it's always 1 point something over 2, and you just use the confidence level.
Okay.
So if this was 90%, this would be 1.90 divided by 2. If it was 88%, it'd be 1.88 divided by 2. Other questions? Where'd you get this? What's going on? Where'd this come from? Alright? So then we go to put it in. So have you got your notes from last time? Calculator. Go stat. Scroll over to tests. Scroll down to A. you for a fraction. Last time it was 20 out of 32. X is like the number of successes, and it's the total number of people. Total number of whatever. So 150 out of 200. My confidence level this time is 99%, so I'm putting 0.99. If I calculate, there's my answer. If you didn't get that, let me know so I can come and see what I can help you with. We getting that? Good. Alright, so then put my answer here, so 0.67, 0.83. That's my answer. I knew 75% of the people in my sample ate cereal. When I generalize that to a bigger population, I've got to give myself some wiggle room, so that puts us to 67, somewhere between 67 and 83%. We are 99% confident that P is between 0.67 and 0.83. Some people ask at this point, like, aren't we supposed to put context in everything? Because all I did was write P here. But if you think back to the beginning, doesn't P have context in it? Like, I defined P as the proportion of people that eat cereal. So there is context in it, I just kind of shortcutted it. Questions on this one anywhere? Did I get a little better the second time? Alright, I'm going to have you try one on your own. Yeah, grab more paper if you want. Talking to me or? Let's say I take a sample of people that have used Bud's landscaping services. What's it called, Bud's? What's your company? Bud's General Contracting. And I found out that 31 out of 100 people are satisfied with their service. 99. I want you to make a 90% confidence interval. So that's the question. So try to follow through, like based on the previous two. I'll go through it in a minute, but I want you to try it on your own. You have like data on that?
The what?
He said a lot. Let me stop you for a second. If it was multiple choice, and it just said, what's the interval? You would not write out all this crap. You would just type it in your calculator. Do like the very last step and answer the question. But there's going to be like free response essays. Like, what's an essay? You have to like show all this stuff. That's what I want you to do. This title should be there. It might have seemed like, oh, Mr. Davis just labeling the notes. But you need a title on it. So you're identifying to the person like what process you're doing. Because we're going to learn 11 different processes. 11. But you get a cheat sheet, right? You get it for all of them. You'll have like 11 cheat sheets. Which I didn't used to do, so you should be grateful for that. phrase here, true population proportion, is key.
So when I do this before, I don't think I'm turned it in.
Okay, so it's not there to be putting up here divided by 2. That's right.
Okay.
So like if I want to use to like 1.95 divided by 2.
Yeah. So I just put it in the top one.
Yeah, it's just
Okay.
divide.
Yeah.
So there's like my intro and my conditions. If you want to check that as you're starting out. Then you rock it out too. You have 2 stuff. Is that a classic? Question on this top part up here. So I gotta scroll. There's like your intro, conditions. says we should have, and then I just want to like summarize for a minute. Question I can answer on this? Alright, so then they'll ask you sometimes to make kind of these conclusions based on it. So, but keep in mind, this is our interval. We're 90% sure that the true answer is somewhere in there. I don't know where. We're 90% sure the true answer is somewhere in there. Would it be reasonable to say that more than half of customers are satisfied with Bud's general contract? Not based on this data, because like, does that interval contain 0.5? 0.5 is way above it, right? So we're pretty sure we're below. Would it be reasonable to say that a third of people are happy with Bud's general contract? Yeah, because 0.33 is like right in, or it's reasonable to say a fourth or a third, anywhere in. So you may have to make kind of decisions based on that. I'm sure Bud's general contract is 100%. It's just an example. Question on that, everyone?